Hey, calculates. I'm back. So, in this next section, we're going to review functions and composition and combining functions and lots of properties about these functions that you've probably forgotten. So, the types of functions that we'll be working with this year are algebraic, and that includes all the polynomials, the rationals, aka fractions, and radicals. Those are self-explanatory. We'll be working with trigonometric. I'm sure there's all your favorite from pre-calc last year, and then exponential and logarithmic. Of course, I made a little red flag stuff over here. You have to make sure that you are careful with the rational functions and that there's no zero in the denominator. You have to be careful with the radicals. Remember, you can't have a negative underneath the square root. And then be careful with logs because you can't take log of a negative number. Okay, so when we are combining functions, by that I mean this. So hopefully you remember all these rules from pre-calculus and maybe even algebra 2, is that when you are doing the sum of two functions, so the composition is a sum, and then I can just add the two functions together. And if the composition is a difference, then I can take the two individual functions and subtract them. And if the composition is a product, then I can take the two individual functions and simply multiply them. And if the composition is a quotient, I can take the two functions separately and just divide them, keeping in mind that the denominator, of course, cannot be 0. Okay, so composition. So you might remember something that looked a little bit like it spelled the word fog, and really it's f of g of x, and of course I can write it with the extra set of parentheses. When I'm evaluating composition, I must always do the function that's closest to x first. So in this example up above, I would have to do g of x first and then take the answer from g of x and plug it into the f function. Now, when I'm trying to find the domain of a composition, I must compose first. So I have to find what the new function is. And of course, the domain is nothing more than the x values, and the range is nothing more than the y values. And when we talk about implicit domain, those are all the ones that work, versus the explicit domain is the ones that were given. So sometimes it'll actually tell us what values we're allowed to use for x. Even and odd function. So an even function is symmetric with respect to, that's what WRT stands for. So symmetric with respect to the y-axis, meaning I can fold it over the y-axis and it'll line up on itself. So an example of this would be this degree 4 polynomial, and if I fold on the y-axis, so this would be my fold line right here, certainly this side would line up on top of this side. So symmetric with respect to the y-axis. And here's the equation. You can even put that into your calculator to get a better look at it. The odd functions are symmetric with respect to the origin. Now, what that means is it has rotational symmetry, so I can rotate it 180 degrees, and then it will line up on itself. So, for example, if I had this degree 5 polynomial, y equals x to the 5th minus x cubed, it would graph like this. And if I were to turn my paper 180 degrees this way, then it would line up on top of itself, which is what makes it odd. Now, definition-wise, if we go back for even function, what it means is that f of x is equal to f of negative x, and for the odd, it's that negative f of x is equal to f of negative x. All right, see you on the next video, kids.